As we've already discussed in class, we can use definite integrals to find the area under curves. And we've touched on this already, and we did an example or two in class last lesson. So here's a graph of y equals f of x, typical function, and we've got the coordinates a and b, so we're finding the area between a and b, there and there. The area will be the integral of between b and a of the function f of x dx. So notice how the right hand extreme of our area goes at the top there of the sign, and the lower extreme there of the area goes at the bottom of the sign there. So at the top we've got the right hand, at the bottom we've got the left hand. Now if the region is below the axis, there's a couple of different ways of going about this, but I suppose the method I've stuck to over time is to reverse the two terminals. So the left hand one is at the top and the right hand one is at the bottom. Now if you make a mistake with that and you put b and a the other way around, you'd actually get a negative answer, and all you have to do there is make it positive. Okay. In fact, some people keep b and a where it is for the below the axis ones and get the absolute value, but we won't go and do that. I think we'll just stick with reversing the terminals. But just bear in mind that if you do get a negative answer, the way to fix it up will be to make it positive, because you've probably got the terminals around the wrong way. But for me, below the axis, reverse the terminals, left on top, right on the bottom. If you've got two areas, you can work them out individually and add them together. So here we've got a function, looks like a cubic function over here. You can see it there. And we've got two areas. We've got A1, okay, and A2. You can see where they are on the diagram. Okay, there's A1 and there's A2. Now A2 is below the axis and A1 is above the axis. So you'll notice here with A1, because it's above the axis, I've got right hand terminal at the top, left hand terminal at the bottom, f of x dx, and for the below the axis region, A2, I've got the terminals reversed, left hand on top of right. So you can calculate the two areas separately, add them together, A1 plus A2, and you get the answer from there. Let's start with this question. We're going to find the area that's shaded in the graph. And the graph here is 1 over x, which is part of a simple hyperbola. Remember, 1 over x is hyperbola. We did our types of graphs earlier in the year. So our area that's above the axis will be the integral 4 to 1 of our function 1 over x dx. And we know how to get definite integrals now. Use our squarish brackets there. Put our integral inside, like so. Remember, it's the absolute value of x, as we discussed the other day, 4 and 1. Okay. Now we haven't got any negative values here, so the absolute value won't be a problem. So our area will be log 4 to the base e minus log 1 to the base e. Remember, in getting definite integrals, we place 4 into our function here, and minus putting 1 into the function. So it's log 4 to the base e minus log 1 to the base e. Okay, so if we just come over here now, our area equals log 4 to the base e minus 0. Remember, log 1 to the base anything is 0, because e to the power of 0 equals 1. So log e, or 1 to the base e equals 0. E to the power of 0 equals 1. Remember our work on logs there. Let's get rid of that. Okay, so we've got the area equaling log 4 to the base c. I notice this is an example straight out of the book, one of the worked examples, and I notice they leave it at that, but I'm wondering whether you could actually go a bit further with this one, because 4 is 2 squared, and we know our log rules that if we've got an index there, we can actually take that out the front. So we get equals 2 log 2 to the base e, and because it's an area we have to give it units, we say square units. So there's our first example of finding an area. Here's the next one. This time we've got a parabola y equals x squared minus 4x, and we're finding the area between 1 and 3. Alrighty. I'm going to use the reversing terminal situation. So instead of 3 on the top and 1 on the bottom, it's underneath the axis, it's below the axis, remember. Okay, so it's going to be 1 and 3. If we mark it up and put 3 and 1, we'll get a negative answer. We just make it positive. X squared minus 4x, bracket that, dx. Let's get the integral there. It's going to be x cubed over 3 minus 4x squared on 2, which is going to be 2x squared, 1 and 3. Okay, so we now insert 1 in for x. We get 1 cubed over 3 minus 2 times 1 squared. Taking away, putting 3 in for x. We get 3 cubed on 3 minus 2 times 3 squared. That's going to be we're going to get 1 on 3 minus 2 minus 27 on 3 is 9, and negative 2 times 3 squared is negative 18. Just rearrange things a bit so I can fit in the answer. So that's going to equal a third minus 2 is a third minus 6 on 3 is negative 5 on 3. And then we've got minus negative 9 equals negative 5 on 3 plus 9. 9 is 27 on 3, so we get 22 on 3, or 7 and 1/3 square units. Is our answer. Next one involves an above and below the x situation, so an A1 and A2. And our cubic function here is x cubed minus 4x, and we've got negative 2, and we've got 0 there, and 2 over here. Alrighty, let's start. Okay, so let's put a 0 in there. So our above axis, our A1, is going to be the integral. It's above the axis, so it's right over left, neg 2 of our function here, x cubed minus 4x dx. So our A2 will be the integral, it's below the axis, so it's left over right, 0 to 2, x cubed minus 4x dx. Let's start by copying our A1 here. Okay, so calculating our A1 here. So we've got the integral of, write out again. It's not a very good integral sign. Let's try again. A bit late at night here, getting a little bit tired. So x cubed minus 4x dx. Okay, so integral of x to the power of 3 is x to the power of 4 on 4 minus 4x squared on 2, which would be minus 2x squared, from 0 to neg 2. So putting in 0 first of all, we're going to get 0 to the power of 4 on 4 minus 2 times 0 squared minus, putting negative 2 in, negative 2 to the power of 4 over 4 minus 2 times negative 2, that should be, negative 2 squared. Okay, so we're going to get 0 for all of that, minus negative 2 to the power of 4 is 16, so 16 on 4, minus negative 2 squared is going to be 4, negative 2 times 4 is, so we've got negative 8 there, equals 0 minus 4 minus 8 equals 0 minus negative 4 equals 4 square units. Okay. I wonder what your prediction is for A2. Might be fairly obvious what it could be, but we'll work it out anyway. So let's now move over and work out A2. We've worked out A1. So here's A2. There's our integral there. Okay, so equals. Same deal again. The integral hasn't changed. It's going to be x to the power of 4 on 4 minus 2x squared from 0 to 2. Okay, so I might just pause it here and do this quickly, and we'll see what happens. Alright, as you might have predicted, we end up with exactly the same thing, 4 square units. Putting 0 in minus putting 2 in. So our total area, our A1 plus A2 equals 4 plus 4 equals 8 square units. Okay, got enough info now to have a go at exercise 9F on page 430.